In this session, I'd like to explain the operational properties. First one is the first translation theorems. We consider the product of the exponential function of exponential at times the function of f. Then we'd like to consider Laplace transform of these functions. The definition of the Laplace transform, exponential minus st times exponential at times ft. We substitute exponential at times ft into the definition of the Laplace transform. Then we combine the exponential minus st times exponential at becomes exponential minus s minus at. So this becomes here. So instead of s, we use s minus a. Laplace transform is expressed capital F s minus a. Instead of s, we substitute s minus a. Then I'd like to show you how to use this first translation theorems in the calculations. Example, we consider the Laplace transform of the exponential 3t and t squares. So 3 is correspond to the a. From the first translation theorems, at first we need to find out the Laplace transform of the ft. In this case, ft is the t squares. So we are going to find the Laplace transform of the t squares. Once we find out the Laplace transform of the t squares, you can substitute s minus a. So in this case, the a equals 3. You can substitute s minus 3. So from the Laplace transform of the t squares, it becomes 2 over s cubes. You still keep the substitution of the s to the s minus 3. Then once you obtain the Laplace transform of the t squares, you replace the s with the s minus 3. So answer becomes 2 over s minus 3 cube. Okay, using the first translation theorems, you can find out the Laplace transform of the function when the function is expressed with a product of the exponential function with any functions. I'd like to introduce the unit step functions. The unit step functions u t minus a is defined as follows. When the t is between the 0 to the a, the quantity of the unit function is 0. If the t is larger than or equal to the a, unit function becomes 1. So from the t is changing from the 0 to the a, it becomes 0. Once it becomes a, it becomes 1. This is the unit functions. Even if the function has a discontinuity at some point, we'd like to find the solutions of the differential equations. This is a method to introduce the functions with the discontinuities at t equal a. Then we'd like to introduce the second translation theorems. So we consider the product of the two functions ft minus a times unit step function of the u is a function of t minus a's. The Laplace transform of such a functions. We follow the definitions of the Laplace transforms. Unit function t is 0 to the a, it becomes 0. If t is larger than a, it becomes 1. The lower limit is changing because between the 0 to the a, unit function becomes 0. It's changing from 0 to the a. The rest is same with the definition of the Laplace transforms. Once we got this expression, we'd like to change the variables from the t to the p by introducing a new variable, the p. P is defined to be t minus a. So from this equation, t equal p plus a. Then dt is equal to dp. Then upper limit and lower limit. Upper limit doesn't change to the infinities, but lower limit is from a is to the change to the 0. And the exponential st is expressed as exponential minus p plus a times s. Then f is a function p. Then this exponential function is split into the two product of the two functions, exponential minus as times exponential minus ps. Exponential minus as is independent of the p. So we can move out of the integrals, exponential minus as. And the rest of the terms is correspond to the Laplace transform of f. So it becomes a Laplace transform of the f. So it becomes exponential minus as times the Laplace transform. So this is Laplace, if we consider the Laplace transform of the f t minus a and the unit function t minus a, then it becomes exponential minus as times Laplace transform of f. For example, if you consider the ft minus a equal 1, then Laplace transform of the s becomes 1 over s. Then we could prove that this one. Laplace transform of the unit function is becomes exponential minus as over s. Once we introduce the second translation theorems, we could also introduce the inverse of the second theorems. Laplace transform of the ft minus a unit function t minus a equal exponential minus as Laplace transform of the f. So from this equation, by applying the inverse Laplace transform, we obtain these equations. Okay, example. If you consider a equal 5, and the Laplace transform of the f is 1 over s minus 3. Then from these equations, you can find that f t is the inverse Laplace transform of the fs. This is equal to the exponential 3t. So we obtained ft is equal to the exponential 3t's. We have already found the a equal 5. So you can replace the t with the t minus 5. Replace this t with the t minus 5. And multiplied unit functions and the t minus 5s. Okay, this is the inverse of the second theorem. So in this first session of the operational properties, I introduced the first translation theorem and the second translation theorem. Okay, this is the end of this session.